thank you very much for being here on a Saturday evening this late. My talk got pushed to the last, but I appreciate you being here first. My name's Hari. I work at Maven Hive. So this is a talk about Ruby memory model. So before I start, how many of you have heard about memory model and know what it is? Show of hands, please. Okay. Let's see where this talk goes. So why did I come up with this talk topic? So I started my career with Java, and I spent many years with Java, and Java has a very clearly documented memory model. And it kind of gets to you because without that you don't feel safe enough doing multi-threaded programming at all. So with Ruby, we've always been talking about doing multi-process for parallelism rather than multi-threaded parallelism, even though the language actually supports multi-threading semantics. Of course, we know it's all single-threaded and all that. But I just got curious, like, what is the real memory model behind Ruby? And I just wanted to figure that out. So this talk is all about my learnings as I went through various literatures and figured out, and I tried to combine, get a gist of the whole thing and cram it into some 20 minutes so that I could probably give you a very useful session from which you can further do more digging on this, right? So when I talk to my friends about memory model, the first thing that comes up to their mind is probably this: heap, non-heap, stack, whatever. I'm not going to talk about that. I'm not going to talk about this either. It's not about optimizing your memory usage, memory leaks, or garbage collection. This talk is not about that either. So what the hell am I going to talk about? First, a quick exercise. So let's start with this and see where it goes. Simple code, not much to process late in the day. There's a shared variable called n, and there are 1,000 threads over there, and each of those threads want to increment that shared variable 100 times, right? And what is the expected output? I'm not going to question you. I'm just going to give it away. It's 100,000. It's fairly straightforward code. I'm sure all of you have done this, and it's no big deal. So what's the real output? MRI is very faithful. It gives you what you expected, 100,000. Right. So what happens next? I'm running it on Rubinius, and this is what you see. And it's always going to be a different number every time you run it. And that's JRuby. It gives you a lower number. Some of you may be guessing already, and you probably know it, why it gives you a lower number. So why all this basic stupid code and some stupid counter over here, right? So I just wanted to get a really basic example to explain the concept of increment is not a single instruction, right? The reason why I'm talking about this is I love Ruby because the syntax is so terse and it's so simple, it's so readable, right? But it does not mean every single instruction on the screen is going to be executed straight away, right? So at least to my junior self, this is the first advice I would give when I started, multi-threaded programming. So at least 3 steps: load, increment, store, right? That's even for a really simple piece of code like, a plus equals to, right? So this is what we really want to happen. You have a count, you load it, you increment it, you store it. Then the next thread comes along, it loads it, increments it, stores it. You have the net result, which is what you expect, right? But we live in a world where threads don't want to be our friends. They do this. One guy comes along, reads it, increments it. The other guy also reads the older value, increments it, and both of them go and save the same value, right? So this is a classic case of lost update. I'm sure most of you have seen it in the database world, but this pretty much happens a lot in the multi-threading world, right? But why did it not happen with MRI? And why did you see the real result? That I'm sure a lot of you know, but let's park that question and just move a little ahead. So as you observed, there were a lot of reordering happening in the instructions, right? Like the threads were context switching, and they were reordering statements. So where does this reordering happen? Reordering can happen at multiple levels. So start from the top. You have the compiler, which can do simple optimizations like loop fusion. Even that can change the order of your statements in your code, right? Next, when the code gets translated to machine level language, goes to core, and your CPU cores are at liberty again to reorder them for performance. And next comes the memory system, right? The memory system is like the combined global memory which all the CPUs can read, and also their individual caches. So why do CPUs have caches? They want to, memory is low, so they want to preload all the values, prefetch it, keep it in the cache, again improve performance. So even the memory system can conspire against you and reorder the loads and stores of the memory registers, and that can cause reordering, right? So this is really, really crazy. Like, I'm a very stupid programmer who works at the programming language level. I don't really understand the structure of the hardware and things like that. So how do I keep myself abstracted from all this, really crazy stuff? So that's essentially a memory model. So what is a memory model? A memory model describes the interactions of threads through memory and their shared use of data. So this is straight out of Wikipedia, right? So if you just read it first, either you're going to think it's really simple and probably even look stupid, but otherwise you might not even understand. So I was the second category. So what does this all mean? So when there are so many complications with the reordering, the reads and writes of memory and things like that, as a programmer, you need certain guarantees from the programming language and the virtual machine you're working on top of to say this is how multi-threaded access to shared memory is going to work. These are the basic guarantees and these are the simple rules of how the system works, so you can reliably code against that, right? So in effect, a memory model is just a specification. Any Java programmers here in the house? Great. So how many of you know about JSR 133? The memory model, double check locking? Okay, some people. Singleton issue? Okay, some more hands. So Java was the first programming language that came up with a concept called memory model, right? Because the first thing is write once, run anywhere. It had to be predictable across platforms, across VM implementations, and things like that. So there had to be a JSR which specified what is the memory model that you can code against so that your multi-threaded code works predictably and deterministically across platforms and across virtual machines, right? So essentially, that's where my whole thing started. I had gone through the Java memory model, and I was pretty much like really happy that someone had taken the pain to write it down in clear terms so that you don't have to worry about multi-threading. Oh, I'm sorry. Sorry about that. Cool. So memory model gives you rules at three broad levels: atomicity, visibility, and ordering. So atomicity, as simple as a variable assignment. Is a variable assignment an indivisible unit of work or not? So the rules around that, and it also talks about rules around can you assign hashes and arrays indivisibly and things like that. These rules can change based on every language and things like that, right? Next is visibility. So in that example which you talked about, we saw two threads trying to read the same value. Essentially, they were spying on each other, and it was not clear at what point the data had to become visible to each of those threads. So essentially, visibility is about that, and that is ensured through memory barriers and ordering, which is the next thing. So ordering is about how the loads and stores are sequenced, let's say you want to write a piece of code, critical section as you call it, and you don't want the compiler to do any crazy things to improve performance. So you say, I make it synchronized, and it has to behave in an as-if serial manner. So that as-if serial manner is ensured by ordering. Ordering is a really complex area. It talks about causality, logical clocks, and all that. I won't go into those details. But I've been boring you with all this, computer science, basics, and all this. Why the hell am I talking about it in a Ruby conference? Ruby is single-threaded anyway. Why the hell should I care about it, right? Okay. Do you really think languages like Ruby are thread safe? Show of hands, anyone? So thread safety, I'm talking only about Ruby, maybe Python, GIL-based languages. Are they thread safe? No? Okay. In fact, they are not. Having single-threaded does not mean it's thread safe, right? Threads can switch context, and based on how the language has been implemented and how often the threads can switch context and at what point they can switch, things can go wrong, right? And another pretty popular myth, I don't think many people believe it here, in this audience at least. I don't have concurrency problems because I'm running on a single core. Not true. Again, threads can switch context and run on the same core and still have dirty reads and things like that. So concurrency is all about interleavings, right? Again, goes back to reordering. I think I've been talking about this too often, and let's not, again, bore you with that. So it's about interleavings. We'll leave it at that. So before we understand more about the memory model and what it has to do with Ruby, let's just understand a little bit about threading in Ruby. So all of you know green threads as of 1.8. There was only one OS thread which was being multiplexed with multiple Ruby threads which were being scheduled on it through a global interpreter lock. 1.9 comes along, there is a one-to-one mapping between the Ruby thread and OS thread, but still the Ruby thread cannot use the OS thread unless it has the global VM lock, as it's called now, the GVL acquire. So does having a global interpreter lock make you thread safe? It depends. It does make you thread safe in a way, but let's see. So how does GIL work? This is a very simplistic representation of how GIL works. So you have two threads here. One is already holding the GIL. So it's working with the OS thread. And now when there is another thread waiting on it, waiting on the GIL to do its work, it wakes up the timer thread. Timer thread is again another Ruby thread. The timer thread now goes and interrupts the thread holding the GIL. And if the thread holding the GIL is done with whatever it's doing, I'll get to it in a bit, it just releases the lock. And now thread 2 can take over and do its thing. So this is the basic working that at least I understood about GIL. But there are details to this, right? It's not as simple as what we saw. So when you initialize a thread or create a thread in Ruby, you pass it a block of code. So how does that work? You take a block of code, you put it inside the thread. What the thread does is usually it acquires a GVL at the top. It executes the block of code, returns and releases the lock, right? So essentially this is how it works. So during that period of execution of the block, no other thread is allowed to work. So that makes you almost thread safe, right? But not really. If that's how it's going to work, what if that thread is going to hog the GIL and not allow any other thread to work? So there has to be some sort of lock fairness, right? So that's where the timer thread comes in and interrupts it. Okay. Does that mean the thread holding the GIL immediately gives it up and says, here you go, you can start and work with it? Not really. Again, the thread holding the GIL will only release the GIL if it is at a context switch boundary. What that is fairly complicated. I don't want to go into the details. I think people who here know a lot better C than me and are deep C divers really. They can probably tell you, how, at what point the GIL can get released, or if a C code makes a call to Ruby code, can it or can it not release the GIL? All those things are there, right? So all these complexities are really, really hard to deal with. I came across this blog by Jesse Storimer. It's excellent, and I strongly encourage you to go through the 2-part blog about, nobody understands GIL. It's really, really important if you're trying to do any sort of multi-threaded programming in Ruby. So, do you still think Ruby is thread safe because it's got GIL? I'm talking about MRI, essentially. So, the thing is, we can't depend on GIL, right? GIL is not documented anywhere that this is exactly how it works. This is when the timer thread wakes up. These are the time slices allotted to the thread acquiring the GVL. There is no documentation around at what point the GIL can be released, can it not be released, and things like that. It's not predictable, and if you depend on it, what could also happen is even within MRI, when you're moving from version to version, if something changes in GIL, your code will behave non-deterministically. And what about Ruby implementations that don't even have a GIL? So obviously that's the big problem, right? If you write a gem or something which has to be multi-threaded, and if you're depending on the JIL to do its thing to keep you safe, then obviously it cannot work on Rubinius and JRuby. Let that alone, even if we give that up, even within MRI, it's not entirely correct to say that you're thread safe because there is a JIL, it will ensure that only one thread is running. So what did I find out? Ruby really does not have a documented memory model. It's pretty much similar to Python. It doesn't have a clearly documented memory model. What is the implication of that? So, as I mentioned previously, a memory model is like a specification. This is exactly how the system has to provide a certain minimum guarantee to the users of the language, right? Regarding multi-threaded access to shared memory. Now, basically, if I don't have a written down memory model and I'm going to write a Ruby implementation tomorrow, I have the liberty to choose whatever memory model I want. So the code, if you're writing against MRI, may not essentially work right on my, my implementation of Ruby. That's the big implication, right? So Ruby right now depends on underlying virtual machines. Even after YARV, you have bytecode compilation, so even MRI is almost like a VM. So that has no specification for a memory model, but it does have something, right, internally. We have to pour through the C code and understand, and it's not guaranteed to remain the same from version to version, as I understand, right? And obviously, JRuby and Rubinius, they depend on JVM and LLVM respectively, and they all have a clearly documented memory model. You could have a read at it. And the only thing is, if Ruby had an implementation, a specification for a memory model, it could be implemented using the constructs available on JVM and LLVM. But this is what we have. We don't have much to do. What do we do under these circumstances? We have to engineer a code for thread safety. We can't bask under the safety that there is a JIL, and so it's going to help me keep my code thread safe. So even I can write multiple multi-threaded code without actually worrying about serious synchronization issues and things like that. It's totally not the right thing to do. I think any which way, Ruby is a language I love, and I'm sure all of you love. So, and it's progressing by leaps and bounds. And eventually we're going to write more and more complex systems with Ruby. And who knows, we might have true parallelism very soon, right? So why not still stay in the same mental block that we don't want to write thread safe code, it's anyway single threaded. We might as well get into the mindset of writing proper thread safe code and try and probably come up with a memory model, right? But I think for now, we just start engineering code for thread safety. Simple mutex, I'm sure all of you know, but it's really, really important for even a stupid operation like a plus equals to. So simple things which I've noticed in Ruby code bases and Rails code bases as well, like generally, is there is like a synchronized, a section of the code has locks and synchronization and everything. It's really safe, but we leave an innocent accessor lying around, and that causes a lot of pain, like debugging those issues. And general issues like state mutation inside methods is really a bad idea. So if you're looking for issues around multi-threading, this might be a good place to start. So I just listed a few of them here. I didn't want to make it really dense talk with all the details. You can always catch me offline, and I can tell you some of my experiences and probably even listen to you and learn from you about some of the issues that we can solve by actually writing proper thread safe code in Ruby. I came across a few gems which were really, really nice. Both of them happen to be written by Hideous. First one is Atomic. Atomic is almost trying to give you the similar constructs like the Java util concurrent package. It tries to, it's kind of compatible across MRI, JRuby, and Rubinius, which is also a really nice thing. So you have atomic integers and atomic floats, which do increments actually in an atomic way, which is excellent. And then there is ThreadSafe library, which also has a few ThreadSafe data structures. I'm trying to play around with these libraries right now, but they may be a good starting point if you're trying to do higher level constructs for concurrency. And that's pretty much it. I'm open to take questions. Thank you. And before anything, I really would like to thank you all again for being here for the talk. and thank the GCRC, organizers. They've done a great job with this conference. A big shout out to them.
Any questions?
Yep.
Hi.
Hi.
For example, if a Ruby code is running in a JVM, in JRuby, how does, because none of the Ruby code is written in a thread-safe way, how does it internally manage? Does it actually, yesterday Yogi talked about the point that tag-to-record is not actually thread-safe. Can you explain it in detail, like in theoretical way?
Okay. What is thread safety in general, right? Thread safety is about how the data is consistently maintained after multi-threaded access to that shared data, right? So Ruby essentially has a GIL because internal implementations are not thread safe, right? So that's why you want to have a GIL to protect you from those problems. But as far as JRuby is concerned or Rubinius is concerned, the implementation itself is not written in C. JRuby is written in Ruby again, JRuby itself, and Rubinius is written in Ruby. And some of these actual internal constructs are thread safe when compared to MRI. I haven't actually taken a look in detail into the code of these code bases, but if they are implemented properly, you can be thread safe internally at least, so which means at the base core JRuby itself might be thread safe. It's only not thread safe because the gems on top of it, which you are trying to run, they may have like thread safety issues, right? Does that answer your question? Or?
For thread safety, right?
Sure. So those gems will not work. That's the point. Like what I want to convey here is whatever gems we are authoring and whatever code we are writing, we might get in. It's a good idea to get into the habit of writing thread-safe code so that we can actually encourage a truly parallel Ruby, right? We don't have to stay in the same paradigm of okay, we have to be single-threaded.
So mutex-based thread management is one way. There's also like actors and futures and things like that. And there's a gem called celluloid.
Yep.
That combined with something called hamster, which makes everything immutable, is another way to do it. Yep. Have you done it or like?
I have tried out actors with Revactor, and lockless concurrency is something I definitely agree is a good idea. Right. But I'm specifically talking about lock-based concurrency, like mutex-based concurrency. This area is also important because it's not like thread mutable state is bad. It is actually applicable in certain scenarios. When we are working in this particular paradigm, we still need those safeties of a memory model. Any other questions?
Thanks for the talk, Hari. It was really good.
Thanks.
Is there a way that you would recommend to test, if you have done threading properly or not? I mean, I know bugs that come out, like intermittent bugs that come out of badly written, not thread-safe code is like the kind of surfaces, Heisenbugs. So you catch them.
At least my opinion, and a lot of people who have done research in this area, their opinion also is that it's not possible to write tests against multi-threaded code where there is shared data because it's non-deterministic and non-repeatable. So the kind of results you get, you can only test it against a heuristic. For example, if you have a deterministic use case at the top level, you can probably test it against that, but exact test cases can never be written for this.
Any more questions?
Cool. All right, thank you so much.